So as I said before, the issue with this is I thought this was actually marble. And as I can see on the internet, a lot of people are saying, "Oh, my marble's not reacting with HCl, my marble," and it's actually quartzite, and it's really hard to tell the difference. So let's just get to the metamorphic tables first. So it's got a crystalline structure here, and it does look like they do look similar. Admittedly, the marble, sorry, comes off a lot easier. These ones seem to be a lot harder. It is quartzite made with lots of quartz crystals, and it'll just break the glass. So I can't. It's not soft. Might be colorless. So they're definitely hard crystals. It's not in random directions because they're sort of melted, because it is sandstone turning into quartzite, whereas the other ones limestone turning into marble. But they're in sheets. They're sort of like flat. So that's sort of like the orientated. If you go random, because you just can't tell, it's not non-igneous because quartz is igneous, and there it is right there. And then you're stuck with igneous rocks, and you're in the wrong tables. So I don't think you can go in the random direction. You have to go orientated, and just say it's orientated against sheet. So that's difficult in itself. So in some senses, you probably can tell if you scratch off the crystals and look at them and just look at the hardness. Quartzite is definitely going to be harder than marble. And so that'll get you to the metamorphic. So if I go down to the metamorphic tables, they're not coming off in sheets. And so I'm left with this whole issue again, of whether it's marble or whether it's quartzite, and people saying, well, it's weathered, that's why your marble is not reacting anymore, or it's got a protective layer on it, or it's too old, or whatever. And what they're dealing with this quartzite, because what I've discovered is even whatever you have, if it's marble, if it's got calcium carbonate, it's highly reactive HCl. If it's not reacting at all, it's not marble. So if I look along here, the first thing I did was just try and double check whether it really is a protective layer, whether the other things work. So I just smashed it up, that little quartzite thing that I thought was marble, into little pieces and threw it into HCl. No reaction whatsoever. So I thought, oh, that can't be. Maybe the metamorphosis is protects it. So I grabbed some calcite and found out that reacted rather violently. I even grabbed a shell, and that reacted very violently. And then I even went for some decomposition. So if it was calcium carbonate, it will react with heat and decompose to carbon dioxide and calcium oxide. And you can see the marble does burn up and react. The calcite does too, and so does the shell, whereas the quartz just does nothing, just gets hot. But I think the final one that really confirmed it to me is, if it's quartzite made up of quartz, it is a mineral. Almost, it's close to being a pure mineral, and so it has a very defined density, 2.65. And so limestone, because this is a mixture of a lot of different substances, not just calcium carbonate, but fossils and so forth, it has a slightly larger range. So it's 2.55 to 2.75, which overlaps with 2.65. But when I did the density on it, 5.25 grams, 24 grams divided by 2 mils, it put me spot on 2.65 as the exact density of quartz. So I thought, oh, well, that's either a massive fluke, or it is actually, because it's marble that doesn't react with anything, which is not going to happen. And it happened to be the 2.65 because it is in the range, or it is quartzite, and it is made of almost pure quartz, and so it is have a really specific density, and you got it spot on. And so I think that's the end game. I think as long as it doesn't react with HCl, if it doesn't react violently, if there's no reaction with HCl, it is absolutely not marble. It is definitely quartzite.